And even though I picked the example, and I certainly don't want to go through any kind of torment where I tried to solve this explicitly for y, I thought I would show you that in fact my software will let me solve this, and I put in like solve for y, and I did come up with these two solutions. So what do you think about that? I thought you'd think that was pretty cool. And so there it is, solved explicitly for y. I don't think I could have done that myself, but hey, the software is pretty incredible. I might have been able to do it with a couple hours of sweat equity. But what I felt about that was, right. So I just thought I'd let the software do it. All right. One more example. Here is an initial value problem. Hooray! So dy dx plus 2y equals 1 with initial conditions. When x is 0, y is 5/2.
I think he's brilliant.
Well, I wouldn't go that far. But the first thing we want to do is try to separate the variables, and of course if we subtract this 2y from both sides, we get dy dx equals 1 minus 2y. Separating, we got dy over 1 minus 2y equals dx. And integrating, it's pretty easy to see why this is negative 1/2 ln of absolute value 1 minus 2y, and this is just x plus c. Well, let's multiply by negative 2, and then we get ln of absolute value 1 minus 2y equals negative 2x plus c. Now that c is really negative 2 times this c, but it's arbitrary, so who cares? It doesn't matter. It won't make any great difference. Oops. No, it won't make any great difference if that happens. So then make both sides exponents for e, so then absolute value 1 minus 2y equals our arbitrary constant times e to the negative 2x. Do you know why that is so now? If you don't, that could cause you some serious problems. Yeah. So see where the c came from here. Remember, this is e to the negative 2x times e to the c. That's your arbitrary constant. All right, so we're still trying to solve this explicitly for y. Subtract the 1 from both sides and divide by negative 2, and I think you would see, you would get this. And by the way, there's no point in me, I mean, I'm writing it as negative c, but who cares? It's arbitrary. It could be a positive c. It wouldn't matter. But we can now at least apply our initial condition. And if you apply our initial condition when x is 0, y is 5/2. X is 0, that makes this e to the 0, and that makes this 1. So 1/2 minus c times 1, so 1/2 minus c equals 5/2. So that forces c to be negative 2, because it's got to be 1/2 minus negative 4/2, so c is negative 2. And we got the explicit solution, y equals 1/2 plus 2 times e to the negative 2x. I thought you'd like that.